Welcome to the Carasoft Data Center Innovation Series, where we take a close look at the tech, trends, and issues shaping the future of data centers in the public sector. I'm your host, Carasoft Consulting CTO, Scott Robon. We have the great opportunity today to speak with Steve Vogelsang, the CTO of Nokia Federal Solutions. Steve has extensive experience and engagement commercially and across the public sector. We'll be touching on the impact of AI for data center architecture, the role of network automation, federal certifications, and more. So, Steve, welcome. Thanks a ton for being with us today. As we get started, could you give us a little bit of your bio, your origin story, and your history in networking?
Yeah, sure. Thanks, Scott, for having me on the podcast. I'm excited about the opportunity. Yeah, I mean, I'm an old school networking guy. Been in the networking industry since the '90s, primarily working on data networks. Started a company in the early 2000s. We built a service provider edge routing platform. Ended up selling that company, and then had an opportunity to come on over to Nokia, which at the time was Alcatel-Lucent. They had another startup that I kind of competed with in my previous company that Alcatel-Lucent had acquired called Timetra. Really nice routing platform, and was just going to make a go at competing with Juniper and Cisco and the big service providers around the globe. So I joined up with that team, and we had a lot of fun. Managed to grow that business, and very successful in taking share, and ultimately built that into the world's leading, excluding China, edge routing business. So those systems are now globally deployed. So that was a fun ride. And then most recently, a few years back, still with Nokia, teamed up with Mike Loomis, who's now the CEO of Nokia Federal Solutions, and we took on the challenge of helping Nokia really to figure out how we can take our products and technology and help the U.S. government with their various missions.
Pretty good. Yeah, no, there's a strong technology heritage with all the points along the timeline that you called out. I think the one big thing is when people think of Nokia, they still think mobility and wireless. And of course, that's still important, but you've got all this other networking infrastructure and services you can do with that and for that. Do you want to kind of call out the distinctions there for folks?
Yeah, it's really interesting making that shift from primarily working with the big service providers. The big service providers know who Nokia is. We've been supplying infrastructure equipment to them. And as you mentioned, we're probably better known for wireless. And that really dates back to the days when Nokia was a phone company. We built smartphones, or actually prior to smartphones, we were a world leader in that business. And we sold that off a while back, really to focus on the infrastructure. And so, yeah, better known for 5G, but over the years, Nokia has been acquiring and merging various entities. And as I mentioned, that merger of Alcatel-Lucent, Alcatel-Lucent was a world leader in IP routing and optical transport. And now we're constantly expanding the portfolio. But one of the areas, maybe 6-7 years ago that we expanded into is data center. And so that really, our routing platforms, as I said, very successful. We were able to leverage a lot of that technology to build out a data center portfolio. And that's kind of one of the newer things that we're taking into the market now.
Yeah, I can so attest to everything you just said. First, as a competitor to Alcatel-Lucent and a partner with Alcatel-Lucent a long time ago in a galaxy far away, but then being able to come over and be part of Nokia for a time and see the whole portfolio and really being able to touch and use and help customers solve problems with all the data networking and with all the mobile networking stuff. And it really is a pretty comprehensive portfolio. Now moving into the data center, what are the biggest challenges that you're seeing with federal customers in the data center environment? It's pretty dynamic right now. There's a lot going on.
Yeah, we see a number of different things. I think one thing in particular is the scale of these data centers is getting bigger all the time. And I would say that really the area we're kind of most focused on right now, where we think we can bring the most value, is looking after the new AI data centers. AI has exploded in the last few years since ChatGPT jumped on the scene with the large language model. And those AI data centers are very different from a traditional data center in that the AI workloads are, these are big distributed memory type workloads running on GPUs. The network really has to be super robust, super reliable, can't drop a single packet, and kind of getting that set up in a way that works with whatever workload you're running on it. It can become a challenge, and this is an area that we look at our data center portfolio and some of the things we've done. One is to leverage what we were doing in service providers, and that comes with performance, robustness, quality, all of those things that you need in a kind of large scale IP network. But on top of that, we've made a big emphasis on automation. We built some really cool event-driven automation tools with our data center solution, and that really allows us to address that challenge in an AI fabric where you've got to adapt that fabric to the workload in a way that is going to maximize utilization of the data center. It's going to improve the performance of those AI workloads, and we can get into a bit more as we go here. But that's I think where we're seeing a requirement and a new capability within the U.S. government as they start to think about rolling out more and more AI type functionality.
Well, so I think this is a good spot to maybe touch on the automation topic a little bit. And as you know, I do some other stuff in the industry focusing on advancing the cause of network automation. One of the things that we see across the board is there's so much of it that's bespoke, and you kind of have to roll your own, and not all shops are capable of that. What is Nokia bringing to the table now that can give me reliable automations in a more consumable way?
Yeah, so as I mentioned, we've got a capability that we've built. It's called event-driven automation, EDA. It's a highly programmatic approach in that everything is driven via a native Kubernetes style infrastructure. It's kind of taking the approach that was used to automate servers and server configurations and managing workloads on servers. We've sort of extended that to the network, utilizing the exact same tool set. So if you're familiar with Kubernetes, you're familiar with how to manage workloads in Kubernetes. We make the network look like it's an extension of that. And to me, as I'm more of a consumer of this, I'm not on the development side, I'm more on the customer facing. This really is going to create an opportunity for us to kind of merge the network in with those workloads. And so we're spinning up an AI fabric. You're going to run, whether it's a learning, tuning, inferencing workload. We can automate it such that we understand that workload, we understand its requirements, and we can automatically configure the network that's going to tune it specifically to that workload. And so if you're doing inferencing, for example, the net result is going to be your tokens per second rate is going to go up because we got the network tuned to that particular inferencing workload. We can, and we think about this, what's happening is not all those workloads are going to look the same. It's not like inferencing is inferencing, because what folks are doing is they're taking kind of a large language model, large reasoning model, they're fine tuning it to a particular data set or a particular problem space. And then the net result is, hey, inferencing for a certain data set is going to look very different from inferencing for another data set. And this is where we think automation can really help to tune the network on demand as you run these different kind of workloads in that data center.
And I would think that even, we've got the explosion of, infrastructure for training, and we will see the steady up and to the right growth of inference applications. That the cost of GPUs and the demand to keep them busy, I would think automation would be even more important in those situations to get the most use out of the infrastructure you've spent a lot of money to invest in.
Yeah, 100%. That's where we see the big opportunity. Because at the end of the day, right, you talk about automation and what is it going to do for you? One, you need to have a need for it. I mean, to be honest, a lot of these data centers, like a normal typical data center that's not necessarily running AI workloads, the way you build those fabrics, there's only so many architectures. It's kind of well known. In most cases, what you want to do is build that fabric and not touch it and just let that data center run. You don't necessarily need to be tweaking it. We think with the AI workloads, it's just a different beast, right? Because you're dealing with, and I mentioned this earlier, it's effectively become a very large, it's a high performance computer is what it is. It's not a traditional data center. You're moving things across these GPUs. It's all direct memory mapped. And it's expecting an underlying AI fabric that is essentially lossless. So as those workloads shift and change, that fabric needs to shift and change to match it. Or, as you said, what the net result is going to be, I get poor performance, I have idle cycles on my GPUs. And so that's where we really see, by taking the tools we built, integrating into that environment, applying the automation, we can make it easy for the end user. So you don't have to worry about, hey, how do I have to tune the network? Just focus on building your AI models, tuning your AI models. We'll take care of automating the network so that when it's running, you're not going to run into a glitch where the network is slowing down your workload.
Yeah, well, to your comment earlier, I think you have Jensen Huang out there saying the data center is the new unit of compute, right? And you've got racks and rows of these things that need to work together, well automated and well orchestrated, right? This seems like an important piece of the puzzle. What other big issues for federal and maybe in particular DoD and other customers on top of what you've seen commercially? How are you helping those customers with scaling out their AI capacity?
Well, maybe I'll touch a bit just on federal, and this will go back to what we're doing now in Nokia Federal Solutions. So Nokia, as you know, Nokia is a foreign company. It's based in Finland, headquarters in Espoo, just outside of Helsinki. And that if we want to go and work with the DoD, for example, there's some security requirements and things we need to work through. And I know you spent some time at Nokia. You know that all too well, and you actually got the ball rolling on this stuff when you were kind of blazing the trails 5-6 years ago. About 4 years ago, Nokia got very serious about wanting to really help the DoD, and that translated into an investment. And that investment took kind of two forms. One was an investment in getting the security certifications required by the DoD to deploy in their networks. I don't know, the folks on listening to this may or may not know all the details. I won't get into it, but basically there's the FIPS certifications, other certifications you've got to get, which means your security modules need to be up to snuff. And it's a kind of a long process. It just takes a while. You got to prove it with a test lab and then submit it. And they've got a large backlog, so it takes a little while. It's a big commitment for a company to do this and keep it up to date. And Nokia is making that commitment. So we now have our leading edge routing platforms, our optical transport platforms are all certified, and we're in the process of now certifying our data center switching portfolio. So that's one big piece to sell into DoT. The other big piece, which is specifically for Nokia, is that as we are a foreign entity, we need to establish what's known as a proxy or a mitigated entity so that we can hold security clearances. And so that's what Nokia Federal Solutions is all about. It's a separate US-based entity. We actually just moved out of Nokia just last month, June 24th. We stood up that company. It's a completely independent US-based subsidiary, and net, it basically means we can hold security clearances, which is critical. If we want to go deploy in these data centers, the workloads running in a lot of these data centers are absolutely classified. And so we just can't go in there unless we have folks with security clearances. We're set up to do that. We're ready to roll out. So those are the couple of the big things in getting set up to go and sell into the government and into the DoD.
I don't want to miss the opportunity to emphasize the level of commitment. Like you did say it was a big commitment, and maybe you don't want to beat your chest so much, but from the outsider perspective now, watching what the investment in establishing Nokia Federal Solutions and all the intense effort for FIPS 140-3, going after the DoDIN APL certifications, it's not trivial at all. So I'll take the opportunity to applaud the work that's been doing. You were kind enough to mention that I helped get the ball rolling, but you all have carried it through. There've been a lot of people, a lot of pieces of that puzzle that have had to come together to make that work. So well done, Glenn. We're glad to see it.
Yeah, thank you. It's a big commitment, and Nokia is 100% committed to keep the investment going, and it's starting to pay off. We are having a good response from the DoD with the various solutions that we have. they appreciate the investment, and they're being very positive in the engagement. So we're feeling pretty good that we'll be able to continue the mission and expand the mission over time.
Well, what do you think the consumption models are going to look like for many, federal customers in terms of AI infrastructure? There's we've seen the advent of the public cloud and the hesitance of, putting workloads in public clouds because of security reasons, but then see security programs and certifications that emerge that have facilitated that. There's a phrase out there called neo cloud now that seems like maybe there are providers that are going to go after this for AI based services. You have your fingers on the pulse of that in any of the federal sector, and interest or apprehension on that?
Yeah, I mean, so within the U.S. government, there's sort of different degrees of apprehension in working with public clouds. I think in general, DoD is probably more open to it maybe than they have been in the past. There
Sure.
certainly are some of the big cloud providers have stood up their GovCloud, which is basically, these are FedRAMP compliant cloud infrastructure dedicated to the DoD. They're ticking all the security boxes. They're deploying equipment in those clouds, by the way, that meet all the FIPS certifications and all that stuff. So I think there certainly is an ability for the DoD to work on public cloud infrastructure, and the public cloud providers are responding to build that for them. You mentioned the neo cloud. And I don't know if this is exactly what you're talking about, but one of the big things we see kind of happening, generally speaking, is a huge investment that's flowing into shared cloud infrastructure companies
Hmm.
for inferencing workloads in particular, right?
Sure.
You see all the big headlines on the massive investment in these large language models and the huge data centers required. I actually saw an article today. They're talking about getting up to a 5 gigawatt data center. It's just enormous. However, once you build the models, when you're using the models, the volume of compute is going to go toward inferencing. I mean, that's actually using the models. And so last couple of years, we're seeing investments shift with the VCs now going after those inferencing data centers. And so that we think that will become a trend as well within the federal government. They'll sort of start with their high performance compute environments, shifting
Sure.
some of those, not all of those, but shifting those into more of an AI type approach with an AI fabric. And then, we'll see probably some huge data centers get built dedicated to the DoD for their kind of base models that they want to build. But then the scale problem we really think is going to be, the fine tuning and the inferencing that needs to go with that.
Yeah, I think we're in a time where there's so much emphasis on model training. That's just the development of the technology. But as there are more and more consumers, or people using inferencing against models, they could see many more endpoints and much more infrastructure required to support inferencing. Um, that could also be more distributed. Do you see this as another thing that can add into edge cloud, or a new type of edge computing application? Have you picking up any read on that yet?
Absolutely. We get involved in edge cloud all the way out to the tactical edge. So, Nokia, part of the portfolio is a 5G tactical solution where we've adapted 5G technology for deployment, by a warfighter on the battlefield for various applications and uses. And one of those, we're seeing increasingly is edge AI workloads. And that goes back to the kind of DoD JADC2 of sense, make sense, and act. And that make sense step is increasingly shifting toward AI to really make sense of the various data that they're acquiring. I think you can imagine other parts of the government that are acquiring large data sets and want to analyze it. We do think a lot of that will start shifting into edge clouds at various locations where you need the answers from that data. And that's a place where I think Nokia is in a good position. We've got a very good portfolio of networking gear that can build out a national footprint, build out a regional footprint, high-end IP routing, optical networking to optical transport, subsea if we need to extend things globally. So all of that is in place in the portfolio. And then when you plug in a data center solution into that, we come along and we not only know how do you build that data center, but how does it need to interact with the larger network? What are the tools and configurations and features that you need to really make that whole thing hum? And so I think it's a unique capability that Nokia brings to the table. We're not expecting that whole end-to-end network is going to be all Nokia. But what we do know is when we plug that data center, our data center switches and data center gateway into a larger network construct as part of an edge cloud, we understand that end-to-end picture and how to make that work extremely well.
Yeah, I can totally see that from my place in the market as well. And I do think that edge inferencing opportunity is going to be 10x, if not 50x or 100x what we're currently seeing for focus on training. And like, not to disrespect training, of course that's important for foundational models, but there'll be much more consumption as we go. uh, as you talk about the different puzzle pieces and the optical piece of the portfolio, I think you're doing some interesting things there too in terms of being quantum ready for encryption. Can you speak to that at all and the importance of that piece of the network?
Yeah, so what we're doing in kind of the security space, and we do this, by the way, in our optical transport solutions as well, is within our routers. So we want to make sure that we have encryption built into those systems. And number one, that it operates at line speed without taking any real hit in terms of cost. It's built into the system. You're not adding cost to activate it. So our routers, for example, our latest generation of routing silicon, we've built in the ability to do AES 256 encryption, wire speed across all the ports. We built in flexibility in terms of what layer we can do that encryption. We created something we call MACsec Flex. So that allows us to do it at layer 2 or layer 3, MPLS labels, things like that. And then we've done the same in our optical portfolio at layer 1. So we built in wire speed AES 256. So AES 256 is considered to be quantum resistant. We sometimes say quantum safe. I like to say quantum resistant because it's a little bit more conservative. That's okay. The challenge today is that most of the key distribution, the key management, and digital signature technology that's commonly deployed today is not considered to be quantum resistant. And what that means is, if and when a sufficiently large quantum computer gets built, that you could potentially decode those key exchanges in digital signatures, which basically means, yeah, an AES 256 is secure, but if I'm doing a key exchange and somebody can hack that, then voila, they can actually get the key and now they can decode the AES 256. So we built a system, which is basically, it's a key management solution. And we manage those keys in a very careful way. And we ensure that when we distribute those keys to the endpoints of that AES 256 encryption, we do that in a secure way. And in essence, we're encrypting everything, every part of that key exchange, also using AES 256. And so that's a solution that's been in place today. Very good feedback from the government folks that we work with. Over time, that's going to evolve. If you're familiar, NIST has now published FIPS 203 and 204, which basically are new lattice-based approaches for the key exchange, as well as the digital signature. So it's early days. We're, like others, are working on really looking at those protocols and working on implementing it. But we've got a solution that's available today, and we'll evolve into the new stuff that's coming out of NIST in the future.
Yeah, I would even raise a sense of urgency for listeners. If you haven't investigated what it means to be quantum resistant and quantum safe, you really should take a look. There's a school of thought out there that depends on the lack of at scale quantum computing because of some of the particularities that quantum computing really requires. But just think about what happens when that first real attacker has stable quantum computing facilities and capabilities, and you're still scrambling to get your vendors to implement quantum resistant and quantum safe protocols and mechanisms. It takes time for stuff to get into equipment and equipment to get into the field. I don't know if you want to pile on to that sense of urgency or any interesting stories you have on that front.
Well, I mean, it is an urgent thing, and what our customers tell us, the ones that are most concerned about this, the way that they think of it is, it's not so much, uh, you could say, well, it's not a problem today because there's not a sufficiently large quantum computer. But if you have data assets that have long-term value or you need to keep secret for a longer period of time, you're already open to a threat, which is somebody could tap a line, store the data, and wait until they have a quantum computer, and then they decode it and they get your data. So it's an immediate problem. It's not something to can down the road. You should be taking action. You should be looking for solutions that can provide you the right degree of security for your network traffic, where you don't have to worry about that future threat of a sufficiently large scale quantum computer.
Yep, definitely agree on that point. One other thing I wanted to tease out, especially for AI infrastructure, is some of the technical evolution that's happening with Ethernet and the Ultra Ethernet Consortium. Can you speak to that and explain to listeners what Ultra Ethernet is?
Yeah, sure. So Ultra Ethernet is, I mentioned these AI workloads require effectively a lossless fabric because you're moving around a lot of remote direct memory access, RDMA type traffic. And the RDMA and the protocols used to transport it are not like TCP. So they don't do flow control and those kind of things. They just expect that they can write to memory. And so what that translates into is that the underlying data fabric, that data network, needs to provide lossless packet transport. Ethernet by default is not lossless. You have buffers and things, but there's chances that your buffers overload and you drop some packets, and that's why we do transport layer protocols like TCP and things like that. TCP or Quick or whatever you choose the one that you like. And so building those fabrics, you got to figure out, well, how do I make this lossless? And that's what the Ultra Ethernet Consortium is focused on, is identifying the functionality that needs to go into the fabric to ensure you can build a lossless configuration that matches the requirements of a particular workload, and do it in an open way. And this is really the key. You mentioned Henson Chen earlier, from NVIDIA. NVIDIA build solutions, but they're closed end-to-end solutions. What the industry wants is open solutions where you can mix vendors. And so at Nokia, we're committed to open solutions. That's why we're part of the Ultra Ethernet Consortium. It's made very good progress. Most of the tools that you need to make a lossless fabric are now available in the latest silicon from the big silicon vendors like Broadcom. And so we can, in fact, build those lossless fabrics today. Those solutions are coming into place. And maybe I'll pause there, but I have other things to say on this concept of openness.
Well, yes, hold that thought. Just on the evolution of Ethernet here, I think you and I have both come from, this decades-long observation where, we always saw Ethernet as just that a local area networking protocol, right? And we had all these robust mechanisms, 25 years ago in the form of Sonnet and SDH for WAN circuits. And who knew that Ethernet would evolve to, be now 1 gig circuits and now 10 gig circuits across, hundreds of kilometers. It shouldn't surprise anyone to see Ethernet evolve this way too for data center and AI workloads. And you're spot on, that openness and having a standard protocol that dozens of vendors are participating in to work on together is going to be key for keeping costs down and performance up for AI workloads.
Yeah, 100% agree. Yeah, I mean, the openness in general is important. We've always competed with Nokia. Everywhere we go, we're always building interoperable solutions. 5G is a very well-defined interoperable end-to-end architecture. We play into that. Our RAN operates with other cores. We've built open RAN so we can put our radios with third-party baseband and our baseband with third-party radios, and we apply the same in data center. It's actually one of the areas we got our real initial start in data center was embracing openness. So one of our first big deployments was with Microsoft, and working with Microsoft, one of the challenges they had is they have their own open source operating system they built called Sonic, and they were rolling that out in their data centers. And they were looking for some help from vendors to really embrace Sonic and make it work across our entire portfolio, including some of the larger, multi-card modular switches, which Microsoft had really focused more on building Sonic into kind of fixed configuration 1U boxes. And so we committed to making Sonic work on our large, big scale data center switches. And ultimately, Microsoft awarded us with a pretty significant business in their data centers. I think we announced that late last year, and we continue to support Sonic. We think it's a great solution. I think there's a lot of places in the government where that sort of openness is important to know they can use an open source operating system. And we're absolutely happy to support that. And we're doing it in a good way. We're really doing it in a way where we're upstreaming the code. We're kind of advancing the Sonic solution. A lot of other vendors will embrace Sonic, but then they kind of make a branch of Sonic that effectively becomes a proprietary implementation. And we've not done that. We've decided we really want to help the ecosystem. And so we're kind of taking that mission to make Sonic work and make it work well.
Yeah, that's an important option, especially as government agencies and organizations get interested in these options. And to your point, Microsoft has submitted Sonic for FIPS 140-3, to the crypto library certification that you mentioned earlier. And we're starting to see RFIs come out from different government organizations for Sonic. So, that's a great way to give those customers choice as they figure out what their operating model, should look like, because there are pros and cons to everything, right? And you can provide a shrink wrap solution, or you can provide an open solution and put the choice in your customer's hands.
Well, and we'll provide a shrink wrapped open solution if they want it as well. So
there you go. Okay, that's a quote. That's going in the show notes. Let me hit one other thing in terms of density in the data center. We've obviously seen, we've gone from 10 gig to, short pauses on 25 gig and 40 gig to 100 and 400 and 800 and 1.6, terabit per second links coming soon. You've got that combined with, again, NVIDIA and other companies packaging more and more in a single rack. So I've got more gear that requires more network connections, that requires special cooling. What are you seeing from a data center equipment density perspective, and how are you dealing with it?
Yeah, it's the cooling challenge, heat dissipation is a big challenge. And I think this is another area, there's been a lot of data center switching vendors over time. I think what we're seeing now with the power density and what you've just described ultimately translates into power density. So the number of kilowatts going into a rack is now, there's racks that are as many kilowatts as was an entire data center. Cooling, that's a big challenge. So, we're now implementing liquid cooled switches where you're basically bringing, liquid directly to the chips to remove heat. I think that's going to be an increasing trend, particularly in the AI fabrics, because those are the densest that you can possibly get. Those fabrics really, really care about latency. And so you can't have a large data center. It's got to all be crammed together very tight. So new types of cooling that has implications on the chassis and how you build it. And again, I think this plays well for a company like Nokia because of our long history in building those robust, reliable service provider systems. We're now seeing, hey, all that stuff we've learned how to do. Wow, you need those kind of engineering capabilities in the data center now, right? Suddenly, all of these things that mattered are starting to matter in the data center. So I think that puts us into a good spot. We build extremely good systems, super high quality. We're very good at heat dissipation. We've been building the highest of high-end routers for years, and that was sort of the bleeding edge in terms of power density. And now we see that shifting into the data center.
Yep, I think we'll see that continue for sure. So, well, as we round the final bend here, what else are you seeing? Like, if you had your crystal ball in front of you, which I know you don't, and it's not fair for me to ask that way, but what are some of the big things coming that you're addressing that we haven't touched on yet? What's really important for what you're doing in data center for the next 2-3 years?
Well, I may take a different approach to answering that. For me, the big thing, and this is part of the reason we do this podcast, and we thank you very much for inviting us. We just want to get the word out that we're here and we've got a really good data center solution. It's a crowded market. There's a lot of vendors, and Nokia's name. We talked about it at the beginning of the podcast. You say Nokia to somebody in the U.S. government, and often like, oh, is that you make those phones, right? I had one of those. And so really it's just getting the word out. Hey, look, Nokia is a networking infrastructure company. We've got a great portfolio. We're now going into the data center. We're bringing many, many years of building, super performing quality systems that are deployed across the globe. We're bringing that engineering prowess into the data center. In our experience in these kind of markets, when we go after them, the hardest part is to break in and kind of establish that we're here and we can help you. And I think that's the message we want to get across today. We're here, we can help you. Once you bring us in, you're going to find pretty quickly that we know what we're doing. We build super robust solutions, and you're going to keep us in the network. And that's been our experience in every other market we've gone into, whether it's 5G wireless, whether it's our IP routing solutions. We come in, we're going to solve your problems. We're going to work with you in an open way. We're going to make sure the products are cost effective. We're going to continue to drive costs down. We're going to continue to drive performance up. And they're going to be super robust and reliable, and you're not going to have to worry about it. So that's a hard message to get across, but that's kind of our goal here is just, if you're listening to this, give us a shot, give us a call. We're here, we're ready to support whatever your mission might be, and we're going to do that in the right way.
Well, that's a completely fair way to use that question, and that's not a complicated message. You were very clear and very direct. So, and look, through the Nokia federal partnership with Carahsoft, we've got a team at Carahsoft that's very literate in Nokia. We've worked together on webinars. We know how to call on folks that are interested in the solutions you're bringing to the table. We'll be really excited to start adding the data center solutions to that really soon. So awesome to have you here. Any last thoughts? Do you want to point people to anything useful or interesting that you're working on or that Nokia is working on for further homework?
Oh, wow. Okay. Well, lots of stuff. I don't know if I want to get into it all here. I will just add, hey, it's been great working with Carahsoft. Y'all great support organization, very well connected. They've done a lot of really good things working with y'all, and we appreciate the opportunity. New stuff all the time coming from Nokia. I mean, we're advancing the technology, working with the government, doing really cool stuff in areas like fiber sensing, integrated sensing and communication, basically turning a 5G network into a type of radar, dynamic spectrum sharing, you name it. We've got engineers and researchers in Bell Labs that are really pushing the limits. So, if you've got a need for any kind of networking solution today, we probably have a really good product set for you. And if you're looking toward the future to solve some future challenges, we've got research capability within Bell Labs and our advanced development teams that can help solve problems maybe we haven't even thought of yet. So appreciate everyone listening.
Yeah, very good. Steve Vogelsang, CTO of Nokia Federal Solutions. Thank you so much for being with us today and the collaborative partnership that Nokia has with Carahsoft. Listeners, thank you for tuning in. Be on the lookout for more episodes coming in the Carahsoft Data Center Innovation Series. Talk to you next time.